Alright, so today we're going to start in 5.6, ASA and AAS. So this is the last little bit of material before the end of the year, and so angle side angle, that's what we're going to start with, and that says that if two angles in the included side of one triangle are congruent to two angles in an included side of another triangle, then the triangles are congruent. So if we have angle A is congruent to angle D, and AB is congruent to DE, and angle B is congruent to angle E, then we know that those two triangles are congruent. Okay, so let's talk about some proofs here. So we have SQ bisects angle RQT and angle RST. So that tells us that those two angles right there are congruent because of the bisection, and then we also know that SQ is congruent to SQ because it's a shared side, and we know that those two angles are the same as well because it bisects RST as well. So for our first reasoning here, SQ bisects angle RQT and angle RST. That's because it's given to us. And RQS is congruent to TQS. This is because of angle bisector. And then angle RSQ is congruent to angle TSQ. This is again because of the definition of angle bisector. I'm running out of room there a little bit, but definition of angle bisector. And then QS is congruent to QS. This is because of the reflexive property. And we know that those two triangles now are congruent because we're looking for ASA, angle side angle. So we have angle, keeps doing that, angle, side, angle, or both those triangles. So we know that those two triangles are congruent because of angle side angle. Okay. Now what I want you to do, see if you can pause the video and just start this next one on your own. Alright, so hopefully you started this one on your own and you found that angle BAC is congruent to DEC. That's given to us, and then C is the midpoint, so that means that those two side lengths are congruent. So I'm going to put down what we know so far. So hopefully you have this information because this is given to us. And now what we want to do is, since we know that C is the midpoint of AE, we know that AC is congruent to CE. And this is because it's the definition of a midpoint. Okay? And then we also know that BCA is congruent to DCE, and that's because there were vertical angles. And then our last one, because we have angle, side angle, so angle, side angle, and then angle, side angle here, since we know that angle, side angle for both triangles, we know that triangle ABC is congruent to triangle EDC, and that's because of the ASA congruence there. Alright, so now let's talk about angle side. So if we have triangles ABC and DEF, angle side tells us if two angles in a non-included side of one triangle are congruent to two angles in a non-included side of another triangle, then the triangles are congruent. So if we know that angle A is congruent to angle D, and we know that angle B is congruent to angle E, and the side length BC is congruent to EF, then we know that triangle ABC is congruent to DEF. Alright, so I'm going to do this first proof, and then what I want you to do is try the next one on your own. So we have that YZ bisects the angle WYX, and we know that angle YWZ is congruent to the angle YXZ. So this is what we know. And so I'm just going to start putting these things on our proof here. So we know that YZ bisects WYX, and that's given to us. And then we also know that YWZ is congruent to YXZ, also given to us. And so because of that, we can tell that the angle WYZ is congruent to the angle XYZ. And this is because it is the definition of an angle bisector. Okay? And now we also know that YZ is congruent to YZ, and that's because it's the reflexive property. And then because we have angle, side, and angle, side, angle, side, then we know that our two triangles are congruent. All right, so now go ahead and pause the video and try this next one on your own. All right, so hopefully you pause the video and you've already filled in what you know on your triangles. So remember, when we are talking about angles that are equal to each other, we just mark it with this little half circle here. So angle ABC is congruent to CED, and we also know that AB is parallel to CE, so the little arrows show that. That shows that those are parallel. And since we also know that C is the midpoint of AD, we can tell that AC is congruent to CD. Now, hopefully you know, because of some theorem that we talked about a while ago, we can see that these are cut by a transversal here, so we can tell that those two angles are congruent. So hopefully you're seeing that as well. And so let's start in with our proof. So we know that angle ABC is congruent to angle CED, and that's because it's given to us. And we also know that AB is parallel to CE, also given to us. And now C is the midpoint of AD, also given to us. And now based off of this information, we can tell that AC is congruent to CD, and that is because that's the definition of midpoint. And then now this is what I was talking about with this little these angles here in the corner. So angle BAC and CECD, those are congruent, and hopefully you can recognize, because they are cut by a transversal here and these lines are parallel, then we know that they're corresponding angles, and so then therefore that means that our two triangles are congruent.